Welcome to our Energy Retrofits and Small Businesses training. I'm Lauren Madison from the Center for Energy Efficiency and Renewable Energy at UMass Amherst, and we are holding this training through the Massachusetts Energy Efficiency Partnership, which is sponsored by National Grid and Eversource. It is great to see so many people here with us this morning, and we have a good group of speakers to talk about how you can save energy and often also improve comfort in small business facilities. The slides went out in the reminder message this morning, and I will put that link in the chat again in a minute. So you can have a copy of the slides, and in the next few days, I will send out a link to the recording as well as information on how to get continuing education units for this session if you would like those. And throughout the session, you can type any questions you have in the Q&A box. Please use that instead of the chat because it's easier for us to keep track of the questions there. We might answer some questions in writing during the session, but we will also have time for discussion at the end. So I'm going to now go ahead with the first section and turn it over to Michael Plouffe and Gregory Sign from Rise Engineering. You can go ahead and share your screen.
Good morning, everyone. As Lauren mentioned, I'm Michael Plouffe, and I'm sitting here with my colleague Greg Sign, both from Rise Engineering. Just going to pull up the slides now and start sharing. Can everyone see that all right?
Looks good.
All right, excellent. So as briefly mentioned, we're going to be going over the one major element for all buildings, which is trying to maximize energy efficiency with building envelope improvements, really trying to keep all the energy that's going into our buildings within the building and kind of not losing it to the outside air throughout the year. So we'll be going over basically all facets of the building envelope, including insulation, air sealing, weatherization, and all the different methods that can be used to identify and promote savings through optimizing the building envelope. I'm going to go over some of the learning objectives and some of the topics that we're going to be covering throughout the presentation here. So the objectives today is really to look at the building and think about all the different facets of how to identify, where you're looking throughout the building, where opportunities might exist, what you may find as you go through your building, and kind of what to look for in terms of what's good insulation or what's a good condition window or door, and where opportunities might exist to increase any insulation or sealing throughout the building to help keep the conditioned air inside the building and stop the exfiltration of conditioned air outside and ultimately resulting in energy loss that we want to minimize. And we're also going to go over the importance of this, how it relates to the second half of this presentation and sizing heat pump systems. It's important to maximize the building envelope performance before, if you end up sizing heat pump HVAC equipment to help minimize the equipment size and increase the performance of the building. And then later on, we'll be going over incentives available from the utilities as well for both the weatherization and heat pumps as well. I'm sure that will be touched on. Small businesses is the focus of this presentation. As defined by Mass Save, those are facilities consuming less than 1.5 million kilowatt hours and 40,000 therms annually. Customers in this bracket can contact the Mass Save sponsor and schedule a no-cost assessment to help them identify the opportunities within their building as it pertains to weatherization or HVAC improvements. Um, Obviously, they're going to focus on weatherization first to help seal up that building envelope. It is worth noting that the customer has a choice to select the contractor that they prefer to work with for these audits and improvements, as long as they comply with the Mass Save certification requirements. And as I mentioned earlier, these weatherization improvements are the key to right-sizing any HVAC equipment that's being sized for the building as part of a comprehensive retrofit to really help maximize the building performance. So defining weatherization, this is a practice of sealing the building and protecting it from the exterior elements. It's very distinct from building insulation. While insulation holds the heat in the building, the weatherization helps keep the air from escaping the building or infiltrating the building from outside. So as noted there, over 1/3 of all the energy consumed and 2/3 of all the electricity are for the buildings. So defining the building envelope, this is the physical barrier between the unconditioned and conditioned spaces within a building. Whether the unconditioned space is part of the building itself, like an unconditioned attic space or unconditioned basement, or whether it's the unconditioned outdoors, having insulation and proper air barriers in these areas is very important to help minimize energy loss through the building envelope. In terms of air infiltration and as it relates to moisture, it's very important that building envelope be addressed properly by somebody familiar with how buildings operate and how to ensure that moisture isn't permeating areas where it shouldn't be that could cause mold or any other building envelope concerns. It is important to take a holistic approach and think about all the different facets that affect the building envelope, whether it be air leakage through penetrations in the building, or as I mentioned earlier, exfiltration, which is in a building with positive pressure inside, air is actually being pushed out of the building. That's all conditioned air being lost outside. And in any buildings with a outdoor air ventilation system, it's important to control air leakage and ensure that only the required amount of outdoor air is being introduced to the building and exhausted. There are ASHRAE standards and for addressing ventilation requirements, and it's important that those are being met and not exceeded in order to maximize building comfort and also energy efficiency. Going to go over some very basic thermodynamics as it relates to air movement throughout the building. As many of you, I'm sure know, heat is always going to move from the area of higher temperature to wherever the lowest temperature is. So basically from that, when you're heating from that conditioned space, it's going to move to wherever there is no heat, which is typically the unconditioned spaces in the building or outside of the building. And it's also important to note that air is going to also move from a high pressure area to the lower pressure. So if a building is positively pressurized within, it's going to be pushing all that outdoor air outside. On the other hand, if there's a negative pressure inside the building, it's going to be pulling in outdoor air unconditioned through cracks in the building and portions of the envelope where it shouldn't be. These are the two major factors for energy being lost in a building. Conduction is the method by which air passes directly through an element, or not air rather, but the heat is lost through the building or gained through the building envelope. Whereas convection is the air movement through the penetrations in the building, gaps, holes throughout the building envelope, plumbing penetrations, wiring, all different areas where air can leak through and carry unconditioned air in or out of the building. This ultimately feeds into the stack effect, where cool air will tend to sink towards the bottom of the facility, and the warm air naturally stratifies and goes towards the roof or the top levels of the building. It's important to try and maintain in a high-rise example like this, it would be important to maintain proper ventilation so that the conditioned air is moving to where it needs to be throughout the building. We have an example of the stack effect here where you can actually see where the cool low pressure zone at the bottom is pulling that vinyl or plastic material in, and the above the neutral pressure plane, you can actually see it's inflating that material. So you can actually see where the heat is causing the pressure to expand and push that out. So it's a nice visual to see how drastic it can be on even a 3 or 4 story facility, like the one we're looking at here. So some of the key areas that we're going to be addressing in the presentation, areas where when you first walk into a building, you'll be able to look for opportunities for insulation and opportunities to improve would be the roof insulation, whether it be a flat roof or an attic area, exterior walls, whether or not they are insulated and whether or not they can be insulated either from the inside or the outside or within the cavity. Basement areas, ensuring that they're sealed and proper vapor barriers are held since they're along the ground floor. Crawl spaces underneath the building, fenestrations, and including doors. That's pretty much it. In terms of air infiltration, most of the areas that I identified in the previous slide are going to contain areas where you should be very focused on minimizing where any air can move uncontrolled along the ceilings and floors and walls, including the plumbing penetrations, anywhere wiring's being run, open cavities that may have just not been sealed up when the building was constructed, any operable doors or windows or inoperable units that should be sealed up, as well as forced ventilation systems. All the ductwork on HVAC systems should be properly sealed so that the conditioned air is actually being delivered to where it's intended to be versus leaking into unconditioned spaces. Typical weatherization opportunities would be installing insulation and air sealing in roofs and walls. This is often done, at least on a flat roof, when new roofing is being done. Other key areas would be installing insulation in floors to help minimize the air movement, replacing doors with either highly insulated or energy efficient doors if they have any glazing in them, or if it's a full opaque door, and making sure that it's rated at a high insulation. And older windows, typically very old units, while they're very expensive, it is good to, when you are replacing them, to opt for the double glazed coated units with some type of gas infill between the glass panes to minimize heat loss and optimize the windows to help reduce solar heat gain during the cooling season. It's also important to, in terms of air movement, to weather strip all those units and ensure that any windows, doors, skylights are properly sealed. In terms of the intentional forced ventilation, sealing the air vents and ducts and exhaust fans can significantly increase the efficiency of the system. know I touched on this earlier, but it is very crucial to ensure that as you're paying to heat and cool this air, that you're actually getting it to the intended spaces and minimizing any losses through the system. And there's also additional opportunities in terms of either semi-conditioned or intentionally conditioned stairways and ceiling unconditioned areas such as elevator shafts and areas above recessed lighting fixtures. Those are all areas where, you know, conditioned air tends to find its way in, even though it's absolutely not needed. Some additional considerations for weatherization are, in addition to the duct insulation, are insulating areas around the foundation, ensuring that proper waterproofing membranes are used to help minimize any moisture creeping into the building. Again, that can create mold problems, and you want to ensure that you're not running into those issues down the road. I'm going to hand the presentation over to my colleague Greg. He's going to go into attic insulation.
Thanks, Mike. So one of the more potentially cost-effective areas or components of the building envelope to address would be an attic space. These aren't necessarily going to be, like as you can see in this photo here, a large space where you can climb into and walk around. It might be a small triangular shaped crawl space underneath a pitched roof. But these are, there generally can be, really good opportunity here to upgrade the insulation or improve it to, result in some good cost-effective savings. You can see in this example here, this is an example of a nice blanket of blown cellulose insulation in an attic space. A nice uniform layer. In terms of, we kind of refer to it as the low-hanging fruit. So this is, buildings that were built 30, 40 or more years ago would have been insulated to code recommended levels at that time, which was based on energy prices from 40 or 50 years ago. Whereas nowadays, we'd recommend 12 to 14 inches as being an ideal level of attic insulation. So if at your facility or the facility you're working at or client you're assisting, you notice that there's 6 inches or less of insulation in an attic space, that generally means there's a good opportunity to improve upon that and yield some good cost-effective energy savings for the client. In terms of inspecting attic insulation, we want to look at the existing material and thickness, identify whether the thermal boundary should be established or is defined at the floor of the attic space or between the rafters, the roof rafters. And we'll go over that. We'll go over roof insulation in a little bit more detail later in the presentation. We also want to look at the type, quantity, and thickness of insulation to be added, and we'll go through some different options for insulation materials to recommend. One other area of note in an attic is the actual access panels or doors leading to that space. Oftentimes those are, poorly insulated or uninsulated and have significant areas around them where air can leak out. So that's something else we want to look at as well. And here's some examples of, I guess the question to ask yourself would be, what do all these structures have in common here? And the answer would be they all have pitched roofs. So any one of these buildings here, you can see this triangular space above the ceiling. And that's what we're referring to as an attic. And those are the areas we'd want to look at to evaluate the existing insulation and see, if that can be improved upon. So here's some municipal buildings. Some other types of facilities here, schools, colleges, office buildings. This appears to be almost like a residential type building that was converted to an office space, and that's pretty common property type. Country clubs. Let's see. Other types of municipal buildings. We got DPW garages, libraries, senior centers. Those are could be a potentially great opportunity for savings. Generally, due to relatively high temperature set points, these facilities are generally kept warmer, so we want to make sure that we're not losing that heat, and for the occupants to be as comfortable as possible too. That's a big component of weatherization. Is not only is it beneficial from an energy saving standpoint, but it can improve comfort for occupants, for customers, as well as improve indoor air quality, because that's obviously a very important thing to factor in. Again, all of these hotels shown here, they all have pitched roofs and attic, and what we refer to as an attic space. Some other small stores, donut shops, gas stations. Franchises, there may be an opportunity, but that would be important to discuss with the building owner as to what their ultimate plans for the facility. In terms of inspecting attic insulation, I'd say one thing first and foremost to note in this photo here, this gentleman is using PPE. You want to make sure that if you're going into an attic space, you're taking steps to protect yourself from potentially hazardous materials, particulate matter, things along those lines. Here, this gentleman's wearing gloves. It appears that he's wearing protective eyewear and a mask. So those are definitely things you want to wear anytime you go into an attic space. And what he's doing here is measuring the insulation thickness through a removed section of floorboard in the attic. So we want to identify the material type and thickness to see, if there may be some cost-effective opportunity there to improve upon the existing conditions. This is a completely uninsulated attic. You can see here that there's no mechanical equipment, no ductwork present in this attic. I believe this is just an exhaust vent, flue vent for perhaps a water heater or boiler venting out through the roof, but there is zero insulation here. Typically, in a case like this, we would recommend insulating the attic floor because there's no distribution, ductwork, anything of that nature in the attic space. And it's worth noting too that during an attic insulation retrofit, it's typically a two-step process where air sealing would be performed initially. We'll go through air sealing in a bit more detail later in the presentation, but that's basically using different types of materials to prevent air or air that you're paying to cool and heat from just leaking out and escaping to the outside. So air sealing would be done first, and then insulation material would be installed, typically to an R49 level. And R value in insulation, the bigger the number, the better the insulator is It's basically how resistant it is to heat flow through the material. Cellulose insulation is often a cost-effective material. It can be applied in a variety of different manners, whether it's open blown cellulose here, which is basically applied as a loose blanket, or it can be also blown into enclosed spaces. As I mentioned, air sealing is generally required as a preliminary step when installing cellulose insulation. But this is an example of a good install. The measuring stick here is probably about 12 to 14 inches of material installed. It's an example of savings. This is from a real life example for a police department. By improving upon their attic insulation, they were able to reduce their heating consumption by 36%, which is pretty significant. I would venture to guess this facility had very poor to zero attic insulation present to realize those types of savings, but it can be pretty significant. Let's see. Roof insulation. So the previous photos we were looking at are cases where there's no mechanical equipment present and in the attic space, and we're defining the thermal boundary or where the insulation should be applied as the attic floor. But there's cases where that's not necessarily true, where we'd actually recommend, or where would actually be recommended to insulate the underside of the roof. So as previously mentioned, in most cases, the thermal boundary should be established at the attic floor. But if there's plumbing present, heating and cooling mains, ductwork, or other obstacles, or a lack of an effective air barrier. So we've seen facilities where there's a drop ceiling present in the finished space, and there's nothing over that, to stop air just from freely leaking out of that space. Sometimes it may make sense to insulate the roof from a cost saving standpoint. Here's a good example of an attic that's full of mechanical equipment, ductwork. There's plumbing present there. So we want to protect that equipment and reduce the distribution losses of the HVAC system. And you can see here that closed cell spray foam insulation was applied to the underside of the roof and the gable end walls here to minimize heat loss through the roof assembly, as well as keep the mechanical equipment in a more temperate environment to reduce distribution losses and minimize the risk of freezing of pipes and things along those lines as well. As I mentioned, we're talking about a facility that might have a drop ceiling with no effective air barrier. We would call that a bypass. A bypass would be where air can freely move between the conditioned space and unconditioned space, and which can be very costly. Generally, closed cell foam is recommended for roof insulation. This is kind of known as what we call a hot roof. A hot roof is where insulation is applied directly or sprayed directly to the underside of the roofing material. That can prevent issues with building use of open cell foam or closed cell versus open cell foam can help minimize the risk of rot and other types of moisture issues from occurring. Here we have distribution ducts, major bypasses where air can freely move between the living space and the attic. So this is a good example of a facility where it made more sense to apply the insulation material to the underside of the roof deck. Insulation materials typically used for roof insulation, fiberglass, It's a typical pink rolled insulation that you see at Home Depot. So it's good material. Spray foam can be a little bit more expensive, but it's more effective. It can be more effective. So we have open cell foam, which would require the installation of a supplemental vapor barrier to prevent potential moisture issues, as well as an ignition barrier. And we have closed cell foam, which is a higher R value per inch, basically meaning it's a more effective insulator. But it benefit with closed cell foam is it doesn't require an additional vapor barrier. But both open cell and closed cell foam require a application of a fireproofing material. Sprayed mineral wool is also an option that can be applied for roof insulation. Densely packed cellulose can also be used, sometimes behind a foam board or other type of vapor barrier. You can see here the underside of the roof was packed densely with cellulose insulation. And you can see this gentleman working inside this space to seal these ducts, to seal heated and cooled air from leaking out of them. Flat roof buildings. So not every building is going to have a pitched roof that can be insulated easily in a retrofit application. So we may need to take a different approach with a flat roof or a typical, membrane roof. So the air and thermal boundary are aligned right at the roof surface here. Can be a more difficult measure to address in a retrofit application. Usually the time to improve your roof insulation is when you actually have to replace the roof itself. So it might not be an ideal candidate for a retrofit, but for example, if we were going to put a heat pump system in, which is going to be covered in more detail later in the presentation, you might have to replace the roof as part of a significant or extensive HVAC overhaul. And, at that time would obviously make sense to improve upon the existing insulation. So there's some opportunity there, but it can be a little bit trickier to address in a retrofit application than a building with a traditional attic space. Mike's going to jump in and talk a bit about air sealing now.
I know we've already touched on this several times, but definitely deserves its own section in terms of a cost-effective and important measure to address in the building. Some of the different aspects to address is the installation of foam, caulking, or any other type of sealant as a method to reduce the air traveling through unintended portions of the building. It'll certainly help with the stack effect that we mentioned earlier to stop the heated air rising through the building. It is important to note that before doing any insulation, the air sealing should be addressed so that you can get the best possible access to the different components of the building where the air is traveling and bypassing the intended thermal boundary. For smaller facilities, I know always in residential buildings, but in some small commercial buildings, some blower door testing can be used to determine the existing air leakage and ensure that any air sealing that is done doesn't over seal the building, because while you do want to minimize air leakage in a building, you don't want to completely seal it. And that would actually lead to issues with building air quality and indoor air quality for the occupants. So in smaller facilities without intentional ventilation, especially outdoor air ventilation, it is important that any air sealing that's performed that it's done to the proper level and not done too much. Areas to address are, as Greg went through, the attics, the tops of the wall plates where they connect to the roof, any plumbing and wiring penetration or open chase, especially areas that should have been sealed up during building construction, but weren't for one reason or another. Additionally, in the building crawl spaces, the band joists along the foundation, the sill plate, open chases, especially in smaller buildings, is often mechanical equipment in the basement that would come up to the conditioned area that air can freely move through. And as part of the air sealing, while it's not particular to the or specific to the building envelope, sealing the duct work in those unconditioned areas will help minimize the loss of the energy that's intended for the conditioned spaces. These are examples of some bypasses. On the right, you can see plumbing penetration where it's coming up from the area below. Looks like it might be a plumbing vent going into the attic, and you can see the air around there is free to travel. There's nothing stopping it from working its way up into the unconditioned attic. On the left, that looks like another area in the attic where insulation was very poorly applied, which could have helped with mitigating air transfer in that area. In either case, it certainly needs to be addressed. These are some more examples. Sorry.
Really, question. Thanks, Ryan, for your question. Ryan had a question here. It says, how do we make sure air sealing is done to the proper level and not too sealed? Is there a measurement that can be referenced? So that's a very important thing to consider. Because you don't want to seal a building up too much, because that can adversely impact indoor air quality for the occupants. So part of a weatherization project, typically we would do like a blower door test, which prior to installing any weatherization measures, that would measure the air leakage rate of the building, and then that could be compared to ASHRAE required air exchange levels, particular to that facility type. So different types of facilities have different types of or different required ventilation rates. So, a school or a restaurant or, a number of different types of facilities might require different levels of mechanical ventilation. So using that blower door test both before weatherization is installed and then after again, can ensure that enough fresh air is being delivered to the space via the mechanical ventilation system. So thank you for that, Ryan.
Yeah, it is important to mention that the blower door would typically be performed on smaller facilities without mechanical ventilation equipment, because that mechanical ventilation equipment, regardless of the air sealing in the building, is still going to be working to bring in the proper levels of outdoor air. In kind, those should be addressed during the air sealing phase, because it should be checked that the dampers and louvers are set correctly in the mechanical ventilation, bringing in only the required amount of outdoor air. But I think that's a topic for a different discussion. But on the smaller facilities, in order to ensure that, if no mechanical ventilation is being done in the building, the blower door testing pre and after the air sealing is performed is the best means of ensuring that the building hasn't been oversealed. So I hope that answers your question. If not, please let me know. I'd be happy to go into it further. So here are some applications of air sealing being done. The picture on the left, you can see the air sealing being done to the attic floor prior to any insulation being installed. In the middle, you can see the plumbing penetration has been fully sealed. It looks like either some lumber or a piece of sheet metal has been installed with some spray foam around it. And on the right, I believe that's a sill plate in a basement with a piece of sheet metal installed and then foamed around to minimize air movement through that area. Some additional applications around brick chimneys are a major area of air loss in a building. Not super common in the commercial sector, more of a residential, but some of the smaller commercial buildings, that will definitely be a concern. And on the right is a good example of the duct insulation being performed with a mastic material to at all those joints where the branches connect to the main manifold for the ventilation air. You want to make sure there's no air leaking there, and that it's all getting to the intended space. So I'll let Greg take over for exterior walls.
Thanks, Mike. So exterior walls, sometimes they can be addressed in a retrofit application. As you can see here in this photo, this is more of a residential type facility, but oftentimes those types of buildings are used either as a mixed use property or for a small business or office. And I would venture to guess this building is probably about 100 years old. So at that time, it would have been highly unusual for this building to have been constructed with insulation in the wall cavities. So, you know, for buildings, I would say prior to the 70s, it's possible, you know, the walls could have been under insulated or completely uninsulated, you know, the cavity spaces themselves. So, you know, the easiest types of facilities to address in a retrofit application, as I mentioned, are wood frame buildings with either wood, vinyl, or aluminum siding. Generally, cellulose insulation is a good material that can be blown in under high pressure by carefully removing sections of the siding, drilling holes, and feeding the tube into the wall to fill that. And then that can be all sealed up nice, and the siding can be reattached, and it's a nice seamless process with minimal touch-up work required to make things look like they did before. Masonry walls, stucco, adobe, those types of buildings, it can be sometimes added from the interior, because obviously, you know, drilling through stucco is going to make cosmetically not be too appealing or tougher to restore to its original condition. So sometimes it can be added via drilling holes through the interior surface, either through drywall or plaster. I guess if you were wondering how to identify whether your walls are empty or whether the walls of a particular building are empty, you know, the first tip off would be, or question to ask yourself would be, how old is the building? You know, if the building was, the facility was 10 years old, I wouldn't investigate that too far, because code would have dictated at that time that it would have had to have been constructed with wall insulation. Whereas with an older facility, it would require a little deeper dig to figure that out. Thermal imaging, so use of an infrared camera, can be a good indicator as to whether it'll give you a clear image, especially on a colder day, whether the walls are empty. You can also drill a small hole in an inconspicuous location and use a probe, a non-conductive probe, so something plastic, to feel around in the wall cavity and potentially draw a piece of that material out. And you want to do these in a few different locations to really get a better sense on whether, you know, if you get an empty probe, you want to check a couple other spots to verify. You know, it's also possible portions of the building may have been remodeled or insulated and other sections are original and untouched. have some photos of wall insulation being installed. Be an exterior drill and blow method, so you can see the sections of siding being removed. Holes being drilled every 16 inches. Note that they're making sure here to insulate the space below this window. The material is added, and then the siding, the holes are plugged, and then siding would be reattached. There's brick buildings, masonry buildings. Sometimes it's really difficult to address those in a retrofit application, in a cost-effective manner. But if a business is a wood frame building and it's older, there may be some opportunity there. Basements and crawl spaces are another area of concern. This photo here shows a crawl space that's been insulated at the crawl space walls. You can see this foam board material, which is applied, air sealing foam, as well as a vapor barrier. So not only can basements and crawl spaces be an area where heat loss is occurring, but they can be a source of moisture loading in a building that, from an air quality standpoint, it's important to address. That's why this poly sheeting was applied over this bare dirt to help keep moisture loading down. That's going to help also, air quality and keep your HVAC equipment from working as hard to, constantly having to be remove moisture from the air. So we'll be looking at the sill of a building is where the framing meets the foundation wall. Any type of bulkhead, oftentimes these are very poorly sealed areas. There may not be any type of door there, so that can be a major source of air infiltration. Crawl space walls, spray foam, rigid foam board, and fiberglass products can be used depending on the application to address these areas. And as I mentioned, making sure that if we have a crawl space with bare earth or bare dirt, we want to make sure a vapor barrier should be applied. While it might not be a direct energy savings measure, it's a really important component of addressing crawl spaces from an air quality standpoint. Other items you might find in a crawl space would be heating piping, whether that be steam or hot water, hydronic heating mains, or domestic hot water. We don't want those items giving up heat to this unconditioned or semi-conditioned crawl space. So it may make sense to insulate the piping, both from an energy standpoint and also to protect freezing in those areas. There's an example of sill insulation. Generally, we recommend using a foam board as opposed to a fiberglass. Fiberglass insulation here can sometimes contribute to moisture issues or rot at the sill plate. So we'd rather see like a foam board or foam board with 1 part foam air sealing installed, or just use of spray foam throughout the entire rim joist or sill. Addressing this area too of a building will help reduce the stack effect. So, we're giving the building less areas to draw air in through, to draw outside air in through. That needs to be, energy needs to be consumed to keep that outside air conditioned. So the more we can seal it at the near grade level and at the ceiling plane of the uppermost level, the more we're going to reduce the stack effect in that building, which that's what we want to achieve here. I mentioned bulkheads. Here's a good example of a wooden bulkhead door, which was retrofit with a piece of foam board insulation and had weather stripping applied to reduce heat loss. I mean, this is a pretty significant hole in the building shell here where this bulkhead stairway is. So sometimes there might not even be a door there to begin with, since something could be fabricated to insulate and seal that opening. I would say, if we're looking at, the most cost-effective measures, the top of the list would be attic insulation and air sealing. Then the next tier down would probably be, our exterior walls and pipe insulation, duct insulation, duct sealing. Windows and doors are also, I would say, maybe one notch below those other items in terms of being able to realize cost-effective savings, but it's an important area to address nonetheless. It can make a big impact on occupant comfort as well. Single pane or older damaged windows and uninsulated doors may warrant replacement. Sometimes they might not necessarily screen for an incentive due to their extended payback period, but can still be an important item to either replace or retrofit with either air sealing or weather stripping. That's oftentimes a more cost-effective option if there's still some life left in that window or door. Replacing worn weather stripping on the door or window, that can be a pretty viable, cost-effective alternative to outright replacing. Sealing of window frames can also help a lot too in terms of either infiltration or exfiltration, as well as improving comfort for occupants. So here we can see some fuzz style weather stripping applied to a commercial door. This one actually doesn't appear that they insulate, this is sealed too well. You can see daylight through that. So there might be some opportunity to seal that a bit better. But it looks like there's a sweep installed on the bottom of the door. Here we have a crew actively working to caulk and seal gaps and cracks around these windows. So let's see. I think that addresses. I think we covered all our slides here.
Yeah.
I see.
I think we may have exceeded our time by a little bit. But,
Yeah, I see.
Yeah, let's move on to the next section, and you can answer the question you have in writing in the Q&A box.
Sure.
Thanks, Gregory and Michael. And can you stop sharing your slides so that we can
Yep.
load up the next ones?
Absolutely.
Now we are going into the heat pump section. So you guys can bring those slides up, and this will be presented by Alex Claremont from DXS New England, which is the local representative for Daikin, and Eric Tobiasen from Mitsubishi. And just following this, we'll have a few minutes from Mass Save on the support that they offer to help implement all of these measures in your businesses. Go ahead, Alex.
Thank you, Lauren. So let's get started here. First, want to talk a little bit about just myself, introduce myself. My name's Alex. I'm originally from north of the wall up in Canada, and I'm a McGill University mechanical engineering graduate, and I've been with DXS New England for almost 4 years now. So Greg and Mike talked about weatherization. We'll get into an intro to heat pump, different types of heat pumps. Then we'll talk about refrigerants, efficiency, cold weather operation and maintenance, and then some options for small businesses and some applications as well before getting into the Mass Save. So let's actually start from the top and talk about how heat pumps work. So a heat pump is no different than the refrigeration cycle, such as your fridge or your car air conditioning. And something important to remember with heat pumps is that it actually moves heat from one environment to another through a temperature gradient. Now, if we go back to the fridge, it actually rejects heat from the inside of your fridge to your kitchen, which actually makes your kitchen warmer. This process of moving heat is actually done through the refrigeration cycle. Now, you might have seen these before, but these are the basic 4 components of any refrigeration system. And these are the compressor, the condenser, the suspension device, whether that's a thermal or an electronic suspension device, and an evaporator as well. Now, in some heat pumps, the expansion device expansion device lives at the condenser unit, such as a mini split or a multi-split, whereas in a VRF, which we'll get into in a little bit, the expansion valve actually lives at the indoor unit. Now, what is a heat pump? It's the same as your refrigeration cycle again, but you can actually reverse the flow. Your outdoor coil actually can turn into your evaporator, and your indoor coil can turn into your condenser. That's why you'll often hear Eric and I refer to the machine outside as the outdoor unit, as it's not always the condenser. It's only the condenser when the system is in cooling mode. In the winter, it becomes the evaporator. So how do you actually reverse the cycle? You don't just turn flow the other way. There's actually it actually always goes out of the compressor in the same direction, but you actually have this device called the reversing valve. And in the summer, you can send discharge gas out the compressor to the condenser outdoors, and that real hot gas can actually get cooled by the warmish air outdoors. In the wintertime, you actually send the discharge gas right to the indoor units, which actually becomes the condenser coils. Again, here in the building, you have the same system in the summer, which is taking heat from inside and rejecting it outdoors. And in wintertime, you take heat from outside and you actually bring it inside the house. Now you're going to ask me, hey, Alex, well, does air at 0 degrees Fahrenheit outside have any heat left in it? Well, it actually does. And unless you're at absolute zero, there's always heat in the air. And 0 degree air for us as humans, Fahrenheit for us as humans is cold, but for a refrigerant, it's actually just another line on the pH diagram that it uses. So why use heat pumps? What's the main benefit? So heat pumps are actually used in cooling everywhere. And we're going to talk about their efficiency metrics in a little bit, but electrifying heating is really where heat pumps come into play. With electric heat, you have 1 kilowatt of heat from the grid, and that gets you 1 kilowatt of heat at your source. With heat pump, you can actually move 2 to 5 units of heat from outdoors to indoors. And if you're using electricity, you can actually now use clean electricity, whether that's from the grid or on-site generation. Now we want to introduce quickly 2 different terms, and those are air source heat pumps and water source heat pumps. Again, there's a lot going on this slide, but you can refer back to it later, but we're just going to introduce 2 terms very quickly. Now, both air source and water source heat pumps both use electricity, and they're both used for space heating and cooling. Both air source and water source heat pumps are also, both air source and water source are also starting to be used for domestic hot water. And again, a big difference between the two is air source heat pumps use outside air as the heat sink or heat source to reject and absorb heat. But for water source, actually use water. And that water can be from a gas-fired boiler loop or from geothermal. Now, if someone says air source or water source heat pump, that's only part of the story, because all this really explains is a heat sink or heat source. Again, very confusing, but hopefully this introducing it helps a little bit, and we'll get into 2 different applications where to explain this a little further. Usually an air source machine is air to air, which is the outdoor machine is actually extracting heat or ejecting heat to the outside and then delivering it to the space with refrigerant lines at the ductless or ducted central unit. Now it can also be air to water, which we won't talk about too much today, but in that case, you're actually delivering water to the space. Now, water source heat pump is usually known as water to air, where you have a condenser water loop in a building and you have a bunch of water source heat pumps that heat or cool the air. Again, very confusing with a lot of different options, but this is just to explain that the word heat pump can actually mean a whole lot. Is it an air source heat pump or is it a water source heat pump? Is it heating or cooling air or is it heating or cooling water? We'll focus mostly on air source heat pumps today, just given the time frame allowed. But feel free to go back to our intro to heat pump session for more details on both options. Now I'm going to start with the different types of air source heat pumps. Top here on the right corner, you can see a PTAC and a rooftop unit. PTAC is often seen in hotels or apartments. It takes heat from the room and actually throws it outside. Some of them actually come with heat pump function as well. Again, that key component being the reversing valve, as we previously talked about. And then it's going to throw heat from outdoors to indoors. These don't actually work down to very low temperatures. So oftentimes you see these with electric heat in there as well. Now rooftop units can also come with heat pumps as heat pumps. Let's say you have an existing mall with five packaged rooftop units serving your space. And let's say those packaged rooftop units need replacing. You could replace them with electric packaged air source heat pumps. And we'll talk about this more in a little bit. Then here on the bottom, you have mini splits or multi-splits. And these are light commercial or residential versions of an air source heat pump. A mini split is where you have a single indoor unit tied to one outdoor unit. And multi-split is where you have multiple indoor units tied to one outdoor unit. With multi-splits, each zone or each indoor unit will have its own control, but the system will have to be in the same mode, heating or cooling. Next, we'll get into another type of air source heat pump. This is probably Eric's and I's favorite topic, but now we're looking at one of the most common commercial air source heat pump, which is VRF, or variable refrigerant flow. With these, each indoor unit has an expansion valve which can adjust how much refrigerant it wants based on the load, and the other unit will in turn modulate the compressor to adjust for the amount of refrigerant needed real time based on what the indoor unit is asking for, hence the name VRF. The outdoor units can actually range quite a bit in tonnage. If three-phase power is available for the larger outdoor units, then you can get up to multiple tons and twin modules together. You can actually get quite large in capacity. If single phase power is available, they can actually get quite small in capacity as well. We're going to go into efficiencies in a little bit, but these systems are really good at part load. At full load, they're pretty good, but it's really at part load that they shine. Now, there's actually two different kinds of VRF. There's actually VRF heat pump and VRF heat recovery. Heat pump is also called switchover system, and heat recovery is sometimes called simultaneous system. What we're looking at here is actually VRF heat pump system, where the entire system has to be in heating or cooling. And let's say the entire system is in cooling, each zone can modulate the amount of refrigerant it receives and cool more or less, but it can't actually go into heating. Again, heat pump systems are most common for small business applications, but sometimes VRF with heat recovery is also seen. This is VRF with heat recovery. It's only available if there's three-phase power available for the outdoor unit. But with heat recovery, you can actually have different indoor units be in different modes. One indoor unit can be in heating while another is in cooling. There's actually an extra component here, if you notice, that makes this happen, and it is those branch boxes. Branch boxes come in very different shapes and sizes. And they're essentially the traffic cop for refrigerant. They'll let either liquid or gas through depending on what's required by the indoor unit. And again, this is the most common type in larger commercial buildings, but sometimes in smaller business applications as well, where the other unit has three-phase power, they're also seen. VRF systems also allow a great deal of different kinds of indoor unit options, which Eric will go into in a little bit. Next, we want to talk about refrigerants. Again, something to keep in mind is that every single kind of heat pump that we've discussed so far uses refrigerants. Refrigerants can contribute to global warming if they escape the system they're in and if they're not reclaimed. The global warming potential of a specific refrigerant was actually developed to compare the different types of refrigerants. And if gases were to escape the piece of equipment, a refrigerant with a lower GWP is not as bad for the planet as a refrigerant with a higher GWP. Now, R410A is actually used in all new air source heat pumps in VRF in the US, with an exception, which we'll talk about in a minute. Now, R410A does not contribute to ozone depletion. You might remember the days of R22, which was actually phased down in the 90s and 2000s and then officially phased out. And as of January 2020, R22 can no longer be imported or manufactured. This was actually due to the ozone depletion of R22. Now, it's still possible to buy recycled R22, which has been reclaimed from existing equipment, or to buy drop-ins, such as Blue On, which is R454A. Now, the phase out of R22 is actually one of the most successful global treaty. Now, let's go back to R410A for a little bit. And the refrigerant itself is actually not bad, but it's a flame retardant additives in the refrigerant that makes it have a high GWP. There's actually efforts to transition into lower GWP refrigerants, which we'll talk about now. By the way, some of you might be aware that the EPA actually tried to phase down refrigerants like R410A in 2015 and 2016, just like they phased down R22, but they actually got sued and lost. And the premise was that the EPA didn't actually have the authority to phase down based on the global warming potential, but they were only allowed to do so based on the ozone depletion potential under the Clean Air Act. And this is actually where the American Innovation Manufacturing Act of 2019, which was actually passed in 2020 as part of our COVID relief bill. And under this act, it gave the EPA the authority to phase down HFCs. It advised the EPA that the production and thus consumption of a HFC should be reduced by 85% by 2036. And that gets us in line actually with the international phase down plan, which is called the Kigali Amendment. Now, manufacturers need to either use recycled or some sort of allowance limits provided to them. And this actually started as of January of this year. Now, unfortunately, there's a bit of a loophole that any manufacturers that don't manufacture equipment in the US do not fall into this. So this does handcuff a little bit American-based manufacturers, but that loophole is currently being looked into. Now, one of the issues today is that the prime alternative for R410A is not actually allowed to go through occupant space yet, and that prime alternative for high pressure applications is actually R32. Now, I do mention high pressures because for low pressure applications, this isn't as much of a concern. But for high pressure, that's really the refrigerant you need to do heating. But currently, again, we can't have R32 through occupied space, and it's going to be a few years before that's allowed at a federal level, and then a year or two to get adopted by states. Our estimate is that we're still probably 5 or 6 years away from seeing R32 in VRF systems in large air source heat pumps. And R32 is actually already started for small split systems for residential applications. Something to over quickly is just a reminder that there's no global warming, if the refrigerant stays inside the system it's made for. And there's no environmental risk with refrigerants as long as they're contained with the system. So how do you actually reduce that risk of them escaping the system? Well, proper install procedures play a large part in this, as well as an afterlife recycling plan or program. Now, after all the environmental benefits of using heat pumps technologies actually outweigh the impact and chance of potential leak. Now, fear not, R410A is not going away soon. All these systems for the foreseeable future will be in R410A. It will continue to be available for the next few decades, just like R22 is available for a few decades for the servicing of the existing equipment. Now, we are excited about the arrival of R32 as a next generation refrigerant with higher efficiencies and lower GWP and just overall less of it. But in the meanwhile, R410A systems are safe to install and go through their life no problem. We just have to focus on quality installs and keeping refrigerants inside of them. Next, let me pass it over to Eric to talk to us about efficiencies.
Great. Thank you, Alex. Go up here. Okay, so heat pump efficiency. This is going to be looking at the cooling side of your heat pump. So your EER, this is your energy efficiency ratio. This would be the same as what you'd see on a typical air conditioning unit at your house. So EER is just the cooling output divided by the electricity input. The big thing with EER is it measures efficiency at peak load. So this is your compressor, your system running as hard as it can. And this typically only occurs about less than 1% of the time during cooling operation. So as Alex mentioned, VRF systems are really good at part load, and that's where the IEER comes in. So that's the integrated energy efficiency rating. And this is a weighted average of EER values at different temperatures to represent performance over the course of a year. So this might look at this looks at your EER at 25%, 50%, 70%, and 100% of your cooling load, and then weights that out to kind of give a better representation of what is actually happening with your system during the cooling operation seasons. And then looking at heat pump efficiency for heating, it's measured by COP, which is called the coefficient of performance. And the COP is basically energy out divided by energy in. So anything below 1, any COP below 1, you're actually getting less energy than you're putting into the system. So if you look at a furnace or boiler, those are about 85%, 99, or have a COP of about 0.85 or 0.99, which means you're actually losing energy for these systems. Electric resistance heat has a COP of 1. The energy you're putting into that electric coil, you're getting out as heat. And then heat pumps can actually get up to higher COPs, so about 2. So the average is around 2. So you're actually getting more heat out of a heat pump system than the energy you're putting in, or more energy out of a heat pump system than the energy you're putting into it, even at low temperatures. So operation in cold weather for a VRF heat pump, basically your efficiency and your capacity is going to decrease because there's just less heat in the atmosphere that you could draw from. Any VRF manufacturer can tell you what your heating capacity would be at lower temperatures, but we're still able to get heat from the outside air even below -10 degrees, and around 0 degrees you're still getting that COP around 2. So again, you're getting more energy out of your system than you're putting into it. If you're looking at heating in low temperatures, there's lots of different approaches. You might have secondary heat, right? So if your heat pump is just not sized to get heating down to -13, you can keep your natural gas maybe to come on when you see that your space temperature is not being hit from your heat pump. And then you could have controls determining changeover of when to change from your heat pump system to your secondary heating system. Heat pump maintenance, it's really set in, forget it. The main thing with heat pumps is a good install. So you're pressure testing your piping lines, you're vacuuming out any contaminants that could be in the system. Heat pumps have inverter driven compressors and high efficiency DC fan motors. And this is all going to lead to long equipment life. All the components are designed to last the life of the entire system, which is typically around 20 years, is what I've heard. But basic maintenance is still required. This would be the same thing that you would do for any standard air conditioning system. So you want to keep your indoor units, their filters cleaned. You want to keep the outdoor coils on your outdoor unit clean as well. And you want to maintain the condensate removal systems, make sure that they're not clogged, make sure they're cleaned. And then if you're going to be using a water source system, you want to maintain the water side infrastructure, pumps, strainers, make sure you clean out your strainers, etc. So looking at some heat pump equipment options, we're going to look at the different styles of outdoor units, indoor units, and go over ventilation. So outdoor units, there's multi-split systems and mini splits. So your multi-split system, these could be single phase or 3-phase, and this is just going to have multiple indoor units connected to the same outdoor unit. Your mini splits are typically going to be, or your mini splits are going to be single phase, and these are going to be 1-to-1. So you're going to have one indoor unit connected to one outdoor unit. And now we're just going to look at some of the different styles of indoor units. These are pretty much the same amongst all heat pump manufacturers. So you have your wall mounted unit. This is really good if you're doing a retrofit application or you just don't have enough ceiling height to put in a cassette. Ceiling suspended unit. We typically see these in retrofits as well, where you don't have access to the ceiling. And these are just butted up right below the ceiling there. Floor standing units. Again, if you don't have any, you don't want anything on the wall or you have lower ceiling heights, this is a good option. So these just sit right on the floor. These come in two different styles. There's one with an encasement and then one without. So the concealed floor standing unit, you could see it's just sheet metal. And this is really so you could build an encasement to match the existing architecture. And then, believe it or not, the most popular style of indoor units is ducted units. So this is basically you're bringing refrigerant piping to the unit, and then you're ducting off the supply and serving your zones. These come in low static, medium static, high static. This is really, see these a lot in hotels, and these are really good if you could actually have some ceiling space to drop the ceiling, put this indoor unit in there, and then you can serve your spaces with ductwork. And then there's the vertical multi-position ducted unit as well. These are popular. And again, you're just bringing refrigerant piping to this unit and then serving your spaces from ductwork. Then there's two different styles of cassettes. There's the one-way cassette. These go up in the ceiling. And then there's four-way cassettes. There's larger and smaller four-way cassettes. And this is really good. You put this in the middle of the room, and then you can get all four corners of your room with conditioned air. So going to ventilation, just a ventilation overview. All buildings are going to require fresh air. Many buildings depend on windows and passive air leakage for ventilation, but this doesn't ensure air quality because now the air coming into your space is not filtered, and this often wastes energy because now you can have on a 95-degree day, you have 72-degree air getting taken over by 95-degree air coming in through the windows. And if you're using a ventilation system, that's when you can integrate accessories to minimize virus transmission, such as filtration, MERV 10, MERV 13 filters, UV lights, or bipolar ionization. So most heat pump systems are only going to provide heating and cooling to the space. So you might need additional equipment for ventilation. Two main kinds are ERVs and dedicated outdoor air systems. So ERVs are just an exchange of cooling and heating through a heat exchanger. There's no additional cooling or heating coil. Basically, there's two fans. There's an exhaust fan that's taking the air from inside your space and exhausting it out to the atmosphere. And then there's a supply fan, which is pulling outdoor air and then serving that into your space or inside your building. These air streams pass through a heat exchanger that transfers both moisture and heat from your exhaust air to your incoming air. So really efficient. All that you're using is fans. And it's really so you're not just, you spent all this energy to get that 95-degree air in the space down to 72 degrees. Instead of just sending that right off to the atmosphere, you can now do a heat exchange so that 95-degree air coming into your space, once it goes through an ERV, might have a temperature of 82 degrees. So those are ERVs. There's also dedicated outdoor air systems. This is just a separate ventilation system, much larger than ERVs typically. Some of these actually have ERVs in them as well, and these provide good humidification that heat pumps just aren't able to meet. And you could also oversize your DOAS system to offset your heating load on VRF. So here's an example of a DOAS system. You can see it has its own separate cooling and heating coil. And one thing to keep in mind is for restaurants may need larger DOAS systems to make up for the amounts of exhaust air in the kitchen. right? So you want to keep your kitchen as a negative space, so you're exhausting a lot of air, making sure the smells don't get out to the restaurant. So just something to keep in mind, that you might require larger DOAS systems. Okay, I'm going to throw it back over to Alex.
Thank you, Eric. So now we're going to be looking at some application considerations. So let's say you have an existing building that does have an existing rooftop unit. A question to ask would be, what is the current type of heating? Does it actually have gas heat? If so, and it's nearing the end of its life, how do you actually electrify that heating? As we previously mentioned, you can use a packaged air source heat pump rooftop unit. But remember, I mentioned they don't actually work down to very low temperatures. So oftentimes you do need backup heating in our climates. Alternatively, we're actually starting to see VRF more commonly used tied to rooftop units as well to electrify that heating. We're starting to see that being used more and more. Now, let's say you do have a conventional condensed unit with a furnace and cooling only coil serving in your space, serving your small business. Well, there's actually great options for those to replace those with completely air source heat pump units, which can do all the heating and all the cooling down to very low temperatures. And there's no issues with that at all. You can actually use the ductwork that's existing as well. It's an option to reuse that existing ductwork to electrifying those types of systems. It's quite easy as well. Now, we talked about a few application considerations, but how do you actually get started? And first step is always to look at weatherization, and Mike and I touched on in their presentation, or that was a presentation, but they went to that quite a bit and repeated that before, in order to size heat pump equipment properly, that needs to be the first step. And we're in complete agreement with that. Before you look at applying heat pump technology, your weatherization aspect of your building should be the first step that you look at. But let's say you do have, with all that being said, once let's see that's all taken care of and you have a contractor on board, whether that's a general contractor or a mechanical contractor, what are some good questions to ask? A good first question would be, why the proposed option is actually a good fit for my building? And has it actually been sized properly? Asking about install and operation costs is also important. And how does it compare to the alternatives? And now, if let's say the equipment's been chosen, is the installer actually familiar with the chosen option? Has he done manufacturer training, and is he going to follow manufacturer best install practices? Those are all important factors to consider, because the installer, again, as Eric mentioned, is going to be the prime person that's responsible for the system and its proper operation over its life. And how is the previous installation that he did of a similar system for this? Again, these are questions we want to just bring up, just educate you guys, just to know that what are some good questions to ask to contractors and the construction team as well. So now we talked about a few applications. Let's show a couple examples both Eric and I have. So I'll get started with this VRF system that is actually serving a restaurant space. And here you can see on the right, you see the ceiling suspended cassette units serving this restaurant. So this does all the heating and cooling for this restaurant space. You have some other additional cassettes here in this part of the space, but in the middle here you have these cassettes serving just this open area. Next, we have another application here where you see both a one-to-one system here if you look at this system here on the left, this is the one-to-one system serving the kitchen space actually in this restaurant. And on the right, you have a heat pump system that's actually serving, they're both serving ducted units, but they're both kind of two different kinds of systems. So we thought it'd be cool to show that here. So here, this is just a ductwork shown. As Eric mentioned, these are ducted units. They're very common type of window units. You don't see them. They're usually hidden away. Sometimes they're exposed, but usually they're hidden away. And all you see is the ductwork coming out from this soffit or this built-in enclosure where all the units are located. So these are the examples I had. Eric, I believe you had some examples as well you wanted to share.
Yep. Just want to go to the next slide. All right, so this was an example of just a one-to-one mini split in a bookstore here in Beverly, Mass. So they just need a little more cooling for their retail area. So they installed a 4-way cassette so they can get all corners of the retail area. You can see the access panel there on the right is rather large. So again, always talk to your engineer or your installing contractor. There might be some local building codes that require access panels larger than recommended by the manufacturer. Next slide. And then this is just an example of a multi-split unit. So again, just one outdoor unit serving multiple indoor fan coil units. This is a restaurant, so you can see the bar area here. They have the one-way cassette. And what this is doing is really just keeping drafts from this window that you could see. So the supply air is directed towards that window just to kind of close the envelope so you're not losing a lot of cooling or heating out to that window. So that's one of the units they used. Next slide, please. Then they used a 4-way cassette in the bar area here. You can see it right there in the middle of the ceiling. And again, 4-way cassettes are great. They allow you to hit all the corners of your space with cool or hot air. Next slide, please. And then the last unit they used was this wall mount. Instead of using the 4-way, as you can see there, they have this chandelier that they wanted to be the focal point of the room. So they didn't want to have offset 4-way cassettes. So they just threw these wall mounts on to kind of serve the space and still allow for that exaggerated ceiling space. Then here's our contact info.
We have some time for questions. So if anybody has any questions on either the weatherization or heat pump section, we can take a couple now while we get the slides up for the last section. Alex, do you want to stop sharing your screen so Mark can get his loaded up? I just put a link in the chat to the slides, so you can all access those right now. And if there are any other questions, you can type them in the Q&A, or I think you can raise your hand and then we could let you ask one. Okay, well, no questions have come in yet, and Mark looks like he's ready. So we'll go ahead and do the last section of the presentation. And if you do have questions, feel free to type them in.
Okay. Can you see my screen okay?
Yes, looks good.
Terrific. Thank you. So hello, everybody. Thanks for being here. And thanks to Lauren for putting this together. My name is Mark Toussaint. I'm the supervisor of the small commercial programs for Eversource in New Hampshire and Massachusetts. And today I'll talk briefly about some of our small commercial incentive opportunities and energy saving opportunities. So just a quick note on who we are. Mass Save is a partnership of all of the utilities in Massachusetts, the regulated utilities, electric and gas. That includes Berkshire Gas, Cape Light Compact, us at Eversource, Liberty Utilities, National Grid, and Unitil. A lot of you will have gas from one of us and electricity from another one of us. And what we try to do, some of you may have facilities that are spread throughout multiple PA territories. And what we tried to do is keep the offerings as similar as possible across the state so that you're getting a consistent experience. So we work together to offer programs that are consistent for you and that will work across the state. This is just an illustration of how important small commercial customers have been to our programs over the years. This is our last program year, and as you can see, micro businesses and small commercial have accounted for 44% of the electric savings. And although I can't see it right now, there we go. And about a similar percentage of gas savings as well. And we're counting on small commercial projects to deliver a significant amount of savings in the coming 3-year plan as well. The main services that we offer, we have education events like this, individual education with customers where they call us and ask questions about how their power is being used in their facility. We can help them solve problems there. We offer a really wide range of incentives and financing to help you pay for energy efficiency measures. And we design them to be easy to use. We have options that where we can do it completely turnkey, send somebody out and have a soup to nuts service where they do the audit, the installation, and everything. Or you can self-serve in a number of different ways. The focus of the program over the next 3-year plan is really in 3 areas. One is traditional energy efficiency that we've done for years. That includes the lighting, motors, heat pumps, VFDs, things like that we've worked with customers on now going on 2 decades. We'll continue to do that to save electricity and natural gas within the territory. But then we have a new focus on decarbonization. That's why we're talking about weatherization and heat pumps today. We're looking to move people to electric heat sources wherever we can, clean up the supply of those electric heat sources, and weatherize the buildings so that you use as little electricity to heat as possible. And then a third focus is on equity. We've taken a look at the data over the years, and we've seen that for a number of reasons, different communities have experienced the programs differently and have had different rates of uptake within the state. And we want to do what we can going forward to make sure that all communities within the state are able to access the programs and are likely to use them so that they can enjoy the benefits that others have enjoyed. Just talk about some of the opportunities. Obviously, the point of the meeting this morning, air sealing and insulation is going to be huge on our programs. And what we're looking to do is make your buildings more efficient to heat and cool. And you'll hear from us in a number of different venues on that topic. You'll hear from our vendors who are looking to do audits for you, looking to do projects with you. And we're looking forward to partnering with you on those. We do a lot of work with refrigeration, restaurants, convenience stores, grocery stores, schools, just a way to help you keep your food fresh and do what you need to do with cooling using as little electricity as possible. And then, of course, while it's less of a focus going forward, LED lights and certainly lighting controls will still remain a huge part of our program because we still have a number of lights to change in the state. As we know, we're finding new projects every single day. And so we'll be out in the field looking for those projects very actively over the next couple of years. And in short, we can look at custom projects as well. We can look at any project that'll save electricity or natural gas cost effectively. Oops. This is just a quick sample of a small business case study in Massachusetts. As you can see, we try to encourage customers to be as comprehensive as they can, because once they start a project, we'd like to get as many measures wrapped into it as we can. So this customer did lighting, refrigeration, they insulated some ducts, and they changed out some aerators. So they got electricity and gas savings. And if you look at the totals there, the cost was about $18,000. We were able to support that project with almost $14,000 in incentive, which left the customer with about $4,200 to pay. And we had a program where the customer could finance that amount at 0%. And it's a very easy program that went directly on their electric bill. And they paid it off just in a little bit over a year. And then after that, they own the measures and enjoy all of the savings from it. So most of our work on small commercial projects is done through a turnkey process, and it's really easy. You just contact us and we can have a conversation with you about your energy usage, kind of pre-screening. We'll identify opportunities and we'll connect you with a vendor who would be appropriate for your needs. They would come out and visit you. They would do a free audit, and their service is they do the audit, they do the installation, they do warranty service, disposal of the old materials, everything from start to finish on the project. You just have to give them access to the building. So you'll get, before you proceed, you'll get a detailed report of what those opportunities are. You'll have a chance to discuss them with the vendor. And once you agree to move forward, we can talk about whether or not you need to finance the rest of the project with us. And then the vendor goes ahead and installs. Very easy process. So we also have, so most of what we do is retrofit projects, but we also have a number of other services and approaches. We have, if a customer would like to look at a specific area of their business, we can do technical assistance studies where we can look at manufacturing lines, we can look at building shell, we can look at anything that needs a little bit of a deeper dive. We do instant rebates where you can go into a lighting or refrigeration, HVAC or food service vendor and get incentives built right into your sale price. So you don't have to wait for any money to come back from us. You don't have to do any paperwork. You just have to show that you're a customer and you buy the materials that day and walk out with it with the rebates already applied to it. We do a new construction program where we can do plan reviews, we can do design charrettes depending on the size of the building. And the goal there is to help you to exceed building code and to build a building that's going to perform at the highest level that it can, because hopefully the building will be up for long past when any of us have passed on. And the decisions we're making today are going to affect generations to come. And then finally, we're working with customers on electrification. We have a brand new, easy to use heat pump program where you can get $2,500 per ton on qualifying heat pumps just by filling out an online form when you buy your heat pump. So this is just the contact information for the various program administrators in Massachusetts. It looks like I have a question or two in the chat. Is there a reason to push for electric heat pumps as opposed to gas heat pumps? So the push for electric heat pumps, Lindsay, thank you for the question. The push for electric heat pumps is a reflection of state priorities toward decarbonization. So we are looking to clean up the electric supply, and you're seeing news, I'm sure, about solar projects, wind projects, more and more renewables on the grid. And in parallel, we're looking to electrify as much as we can. So you've seen efforts toward electric cars, electric heating sources, so we can move those prior fossil fuel usage onto renewables as time goes on. So that's the state strategy there, and that's what we're helping to implement. And then somebody asked, what is the comprehensive portion of the incentive that I discussed? Is that due to multiple measures that they implement? Yes, it is. So we at Eversource give a bonus typically for comprehensiveness within measures because it is important to us to hit as many measures as you can as you go to see a customer. Because often those measures interact with each other, and the finances certainly interact with each other. So we want to get as broad of a look at a building as we can, and go as deep as we can with the customer on that first interaction. Now, they don't always happen all at once, and we can work with you over a number of years, but we do try to get you to look beyond just the single measure that we started with. So in the past, it's been very heavily lighting. Now we're trying to do lighting and weatherization and some gas measures all at once. That's all the questions that I see. If anybody else would like to ask any, I'd be happy to answer.
Yeah, if there are any other questions about anything we've talked about today, again, you can either write them in the Q&A, or if you raise your hand, I can unmute you. Oh, Mark, there's another question about incentives.
Can you please go over incentives for weatherization, heat pumps, regular gas furnace, and lighting? So the best thing to do for that, because the incentives do change over time, best thing to do for that is to go to masssave.com. That site will show all of the current incentives that we offer at any given time for each customer class. So you might have different incentives based on whether you're a commercial customer, residential, or municipal. And then sometimes you might even have different incentives or pathways depending on what size customer you are. So I would visit that site, and that'll list all the incentives for you. So Ryan Donovan asks, are financing options for weatherization and heat pumps coming soon? I'm actually really glad you asked that. So we have been working with a third party called NEIF, N-E-I-F, National Energy Improvement Fund. It's currently live in Connecticut. We will have it live in Massachusetts and New Hampshire soon. And what NEIF does, it's a kind of a clearinghouse for energy efficiency financing. And they would shop among a number of different lenders with you to help you find a lender to cover your projects. And then using part of the incentive, we can buy down the interest rate to as low as 0%. And that would apply to weatherization and heat pumps, which we haven't been able to do yet. Our incentive dollars different based on existing fuel types used. We have different types of incentives, I would say, for electric and gas, if that's what you mean. So certainly they're structured differently. And I would talk to your program administrator about what applies to your specific situation.
Okay, Mark Anthony, I'm unmuting you so you can ask your question.
Hi there. Can you guys hear me?
Yep.
Yep.
Excellent. Excellent. Yeah. So my name is Mark Anthony. I do outreach for World Energy Efficiency Services for the Mass Save program. And frequently when I'm speaking to Eversource customers to do, their walkthroughs, I get the question, can I have someone from Eversource reach out to kind of verify the validity sometimes? I don't know if you guys have any resources somewhere I could send them to say, hey, yeah, no, we're partnered with Eversource. Here's that info.
Yeah, absolutely. So Mark, we've made some efforts with our marketing group to give you business cards and flyers and things like that to confirm that relationship. But they can also call, they can call myself, they can call Pat Owens, Maureen Kiley, or Kim Kiernan, whoever you happen to be working with on the project, and they can certainly confirm that with the customer for you.
Excellent. Much appreciated.
Thanks.
Great. Are there any other questions for any of our speakers?
Richard, I think.
I will.
Yeah.
Okay, Richard, you should be unmuted.
Okay, thank you. I just want to follow up. You can hear me, correct?
I
Yep.
can.
I just want to follow up what the gentleman said a minute ago. I get that a lot. They want to see ID. We don't have photo IDs because whatever the reason is for that. I do have a card that says Eversource on it. I've actually called that number and asked them if they knew who Richard Farrell was. They had no idea who I was or what company we even work for, which was just disheartening. So it doesn't happen a lot, but it happens consistently where someone will say, hey, I need to see your ID. I don't have an ID. And they say, well, let me call this number on the card. And then 844-877-1400 is the number that we have on our Eversource cards. And those people don't know who we are, the company we are, or even who I am. So again, it's not a big deal, but it is an ongoing issue for concern of people, because you want transparency, you want people to feel comfortable, and that's a big part of making the sale and getting the energy products out there.
So Richard, you should, if you're going out on our behalf with one of our contracted vendors, you should have a badge. And if you don't, you can talk to Pat Owens about getting that in the works. That's pretty easy to get.
I believe it was requested in January.
Yeah, we had some changes within our security group, but that's back on track and we're issuing those again. So we can get that for you pretty easily. And I'll get you the numbers for individual staff to call if you have any questions about
Yeah. Again,
confirming
it's
who
not
you
a
are.
huge problem, but it's kind of frustrating if you're trying to tell somebody and then they make the call and it comes back and it looks like you're being disingenuous to the customer, which is
Sure.
not good for me or certainly for Eversource.
No, I got you. We'll work on that with you.
Thank you.
Okay, well, thanks again to all of our speakers today.